Section 1.2 of Advanced Chemistry. We're going to review and refresh ourselves on the system of international units and the metric system for units of measurement. So when you look at the SI units, the system of international measurement, and the standard units, remember that our standard unit for mass is kilograms, even though a lot of times in chemistry we work in grams as our base unit. Meters is length, seconds is time, temperature is in Kelvin. Now, why do we use Kelvin? Anyone remember why we use Kelvin? Yeah, remember that Kelvin doesn't have a negative temperature. The coldest possible temperature in Kelvin is 0. Amount of a substance is a mole, with its abbreviation being MOL, just dropping the E. A couple other SI units that are mostly used in physics on this during their electric current and luminosity or intensity. So when we use prefixes as well, so instead of just saying I have a 1 followed by 9 zeros meters, I'm going to say that is a gigameter, or a billion meters is a gigameter. Now remember, what you're going to have to remember is it'll be good to know giga down through pico. And pico is to the 1 trillionth. So giga, mega, kilo. Don't worry about deci as much. Deci is just 1/10, centi, milli, micro, nano, and pico, and then each one of those has an abbreviation as well. Remember, micro is kind of the goofy looking U, so that you can remember that. You will need to know those. It's good to know the smaller quantities more, because that's what we'll be dealing with in chemistry as well. Volume. We use liters in chemistry. We use liters and milliliters, and in fact milliliters is probably the biggest used unit. Now what you'll notice here, to highlight on the bottom here, a milliliter is a cubic centimeter. Now when you, for those of you maybe going into the nursing profession, they sometimes give medicine in cc's. Well, cc's just stands for cubic centimeter. 1 cubic centimeter equals 1 milliliter. So if I'm giving 40 cc's of something, 40 cubic centimeters, I'm administering 40 milliliters of medicine to that. And there's a lot of talk about this in the pediatrics community, that when they give medicines to parents to give it to their children, that they're not giving accurate doses, because they're not, a lot of parents don't understand the use of milliliters, even when it can be given on a gauge or a syringe. So 1 cubic centimeter is 1 milliliter. Temperature, the definition of temperature is the average kinetic energy of particles in a sample. So really how fast particles are moving in a sample. Now let's not get caught up in, all right, we know water freezes at 0 Celsius, boils at 100. I don't care if you know it in Fahrenheit, I'm more concerned about Celsius. How do we convert one to the other? For the most part, Celsius is okay. When we start using Kelvin, it'll be noted. If you want to use Kelvin all the time, not going to hurt my feelings. We use Celsius for water and other liquids, Kelvin when we really start talking about gases. And how do we convert from one to the other? Well, with Kelvin, here's the money equation. Kelvin is equal to Celsius plus 273.15. Last year we did it without the 0.15. This year we're going to be a little more accurate and precise. We're going to have the 0.15. So Kelvin is equal to Celsius plus 273.15. Everything will be given in Celsius. You'll measure in Celsius, or a question will give you in Celsius. You'll have to convert to Kelvin. For pure curiosity's sakes, if you've ever had to convert from Celsius to Fahrenheit or back and forth, for example, if you're like a foreign exchange student and you get super confused, you can do the 9/5 plus 32, or 4/9 minus 32. You do not need to know that. That's just kind of if you're really interested in that. Density, real quick. Density is telling us the proportion of mass to volume in a substance. Every compound has a different density. It is unique to that substance. And density is equal to mass divided by volume. Its units, therefore, are grams per milliliter, or kilograms per liter, or we could go kilograms per meter cubed, or we could do grams per centimeter cubed. Since we have varying units for mass, we can have varying units for volume. Meters cubed. So you could have a variety of units for density. Uncertainty in measurement, what are we going to talk about when we talk about uncertainty in measurement? We're going to talk about two things. We're going to talk about significant figures, and we're going to talk about the difference between accuracy and precision. And when you are accurate and precise in the lab, different devices have different uses and different degrees of accuracy. So in the lab, if I'm going to measure 100 milliliters, a graduated cylinder is going to probably suffice. However, if I'm asked to measure, I want 1 microliter, there are devices that will use 1 microliter. And a micropipettes is something that you could use. So you kind of have to consider what device you're going to use in lab. We talked about significant figures. We are only as accurate as our least accurate measurement. So remember that. We're only as accurate as our least accurate measurement. Quickly reviewing sig-fig rules. All non-zeros are significant, which means if I had a number, 319, all three of those sig figs count. Zeros between two significant figures are themselves significant. So if I had 2001, in this example I have 2 zeros between 2 real numbers, so I have 4 significant figures. All right. Next example. Zeros at the beginning of a number are never significant. So for example, 0.000034. These 4 zeros do not count, therefore that number has 2 significant figures. And lastly, zeros at the end of the number are significant if a decimal point is written in the number. So if I have 160 decimal, that decimal now means that I measured that spot, and we have 3 sig figs here. We will work on some sig fig practice, and we'll work on some sig fig math, because we are going to have to add and subtract using significant figures, and we are going to have to multiply and divide using significant figures. When we add and subtract, answers are rounded to the least significant decimal place. So for example, if I take 6.5 plus 1.25 plus 3.000. Let's add those together, and what do you get? You get 10.75. However, the least significant decimal place, if we look at my numbers, this has 1 significant decimal, this had 2, and this had 3. So my answer is going to be in 1 significant decimal. So when I do this, my answer here is really going to be 10.8. When you multiply and divide, all you're going to do is you're going to take the least amount of significant figures in one particular calculation. So if I had 12 times 10, we know 12 times 10 is 120. However, 12 has 2 significant figures, 10 has 1 significant figure, which means my answer needs to be in 1 significant figure. And 120 in 1 significant figure is going to be 100. So really hammering home the importance of significant figures. We will practice this in class, since we will review a little bit of this. Accuracy versus precision. Real quick here. If I have a bullseye and I am aiming for the bullseye, and I get around the bullseye, that is accurate. If all my measurements are very close to one another, I am precise. And ideally, we want to be accurate and precise. Dimensional analysis, we'll practice dimensional analysis in class tomorrow. We'll review with this. This is using the railroad tracks. We'll do a couple of examples to refresh your memory, but that is doing railroad tracks. Bottom line with dimensional analysis is just like you can cancel out fractions, you can cancel out units. So for example, I want to convert 8 meters to inches. I'm going to convert meters to centimeters, centimeters to inches. So what we did here is I start with my one fact that's given to me. 8 meters. I put meters on the bottom, centimeters on top. The numbers are the conversions. In 1 meter, there's 100 centimeters. I would cancel out my meters. I'm now in 100, and now I'm in centimeters. I want to go centimeters to inches, canceling out centimeters on the bottom, inches on top. And 1 inch, there's 2.54 inches. Multiply those together to get 315 inches. We will work more with sig figs and dimensional analysis tomorrow as a review. You will have a quick mini quiz on some sig fig questions, however, right after this is done, which is now. If you have questions, we will talk about them tomorrow.